Okay, so let's see how you did on this one. So we have Pat, Sam, and Devin. And we are looking at their ages. And we have Pat is 7 years older than Sam. So I'm going to let Sam's age be X. And Pat's would be what? X plus 7. 7 years older. Devin is 4 years younger than Pat. So Pat is X plus 7, and from that we're going to subtract 4. So that ends up being X plus 3. So now we have those three ages, and we know that their sum is 43. So X plus 7 plus X plus 3 equals 43. What's our next move? Combine X, and X make 3X, and 7 and 3 make 10. So 3X plus 10 equals 43. What's next? Minus 10 from both sides. 3X equals 33, and then divide by 3. X equals 11. Now we've solved the equation, but we have not answered the question. The question asks, find their ages, find all their ages. So if X is 11, that means Sam is 11. Pat, X plus 7, so that'll be 11 plus 7 is 18 for Pat. Devin is X plus 3, so 11 plus 3 is 14 for Devin. Any questions? Okay. So just a review of some of the word problems from yesterday. I know people usually dread the word problems a little bit, so the more we do, the more you get used to them. As this course goes on, unfortunately, we do have more and more word problems because that's your next level is usually heavy word problems because life is a word problem. A lot of word problems. Yep. But it's survivable. Okay, so one of the other things that we did on Monday was we looked at something like this. And what did we do with that? We called it distributing, and we're just multiplying it through. 7x squared times the 3x made 21x squared. And 7x squared times negative 5, negative 35x squared. This actually should be x to the third, shouldn't it? 21x to the third minus 35x squared. I was wondering why everybody was looking at me funny there for a second. So we just multiply that out by distributing it through like that. Well, today what we're going to look at is we're going to look at a process called factoring. And we factored our whole numbers. Remember we did the factor trees? We'd have something like 60, and we went to factor it. It would be, well, 10 goes into 60. So 10 times 6 makes 60. 10 can be divided into 2 times 5. 6 can be divided into 2 times 3. So there's your prime factors. 60 prime factors into 2 times 2 times 3 times 5. Just listing them all out, smallest to largest. When we're factoring an algebraic number like this, what we're looking for is a single factor that we can take out of it. But what we're generally looking for is something called the greatest common factor. That's the last time you'll probably see me write that out all the way. From now on, it'll be known simply as GCF. And if you recall, when we were doing numbers, if I want to do the greatest common factor, let's say we had the greatest common factor of 60 and 48. And we factored 48 was 2 times 2 times 2 times 2 times 3. We could factor them out and look at the common factors. They each have a 2, they each have another 2, and they each have a 3. And if we multiplied those together, 2 times 2 is 4 times 3 is 12. 12 is the greatest common factor of 48 and 60. It's the largest number that divides into both of them. So here we need to find the greatest common factor of 21x to the third and 35x squared. To do that, we can use this factoring again. Notice I'm ignoring the negative here. That's just going to come into play later when we go to divide back out our greatest common factor. So 21 is just 3 times 7 for the numbers. X to the third is x, 3 x's. 35 is 5 times 7, and x squared is x and x. So greatest common factor. The C stands for common, which means we are looking at common factors. What factors do these have in common? They have a 7. They have an x. And they have another x. If I multiply that out, 7 times x, I get 7x squared. What's that? Nope, I just do this row. 7 times x times x. This is 7 times x times x. Both of them come out to be 7x squared. So let's look at that for right now, of finding those greatest common factors when there are variables involved. So let's find the GCF of 120 x to the third y and 90 x squared y squared. Well, you might not know all the factors of 120, bless you. So we can split it up and do a factor tree. It ends in a 0, so I know it can be divided by 10. So 10 times 12 is 120. 10 can be split up into 2 times 5. 12 can be split up into 2 times 6. And 6 can be split up into 2 times 3. So the factors for 120 are 2 times 2 times 2 times 3 times 5. The x to the third is just 3 x's, and then we have the y. 90. If I factor out the 90, I have 2 times 3 times 3 times 5. I'll let you guys do the factor tree to get that one out if you need to. X squared is just x times x. Y squared is just y times y. Now let's look at what they have in common. 2. They have a 3. They have a 5. So that's going to give us 2 times 3 is 6 times 5 is 30 for the numbers. But they also have variables in common. They have an x and another x. What's that going to give us? X squared. And they have a y, which is just going to be y. We try to find the GCF of of 70 x to the fourth y squared z to the third, and (50) x squared y to the third z. If you factor 75, it's 2 times 5 times 7. Or 70, sorry. If you factor 70, it's 2 times 5 times 7. Yeah, it's going to be one of those days. I was doing that in my first class today, too, all the time. Saying one thing and writing another. So, yes, factoring 70 is 2 times 5 times 7. X to the fourth is 4 x's. Y squared is 2 y's. And z to the third is 3 z's. If you factor 50, is 2 times 5 times 5. X squared is 2 x's. Y cubed is 3 y's. And then z is just z. So if we look at what they have in common, they have a 2. They have a 5. For the numbers, that's it. So what's 2 and 5 make? 10. For the variables, they've got an x and another x, and that's it for the x's. So that would be x squared. For y's, we've got 1y and a second y. That would be y squared. And for z, just got 1, so it's just z. So if we look at these, there is a pattern developing. So let's start out by looking at the numbers. 120 and 90. The 30 is just the greatest common factor of 120 and 90. The variables don't affect the numbers at all. Same down here. 10 is just the greatest common factor of the 70 and the 50. So now let's look at what happens with the variables. We started with x to the third and x squared, and we ended up with x squared. We started with y and y squared, and we ended up with just y. Down here, we started out with x to the fourth and x squared, and what did we end up with in our answer? X squared. We started out with y squared and y to the third, and we ended up with y squared. Z to the third and z, and we ended up with z. Can you see a pattern developing with those variables and their powers? Yeah, it's the smallest one. It's the lower power. The smaller power between the two. It's always going to be, for greatest common factor, it'll always be the smaller of the two powers, the lower of the two powers. So if I have 16 x to the 8th, y to the third, z to the 5th, and 24 x to the 5th, y to the 5th, z to the third. For 16 and 24, what's my greatest common factor? 8. X to the 8th and x to the 5th? X to the 5th is the smaller power. Y to the third and y to the 5th? Y to the third is the smaller power. For z, z to the third is the smaller power. What do you think? No, you don't have to factor them out. Especially if you can see with the numbers what the GCF for the numbers is going to be. Really, the factoring is more for the numbers because the variables are kind of obvious once you know it's just the smaller power. So why do we care? Why are we finding GCF? Well, let's go back to that original example we had up here. where we multiplied that out and we got 21x to the third minus 35x squared. If we look at that, if we find the GCF of 21 and 35, what's it going to be? Greatest common factor, 21 and 35. 7. For x to the third and x squared, x squared. When I was doing whole numbers, if I did like 60, if I was factoring 60, let's say I decided to take out a 10, how did I find what went over here? 60 divided by 10 left me with 6, right? So I found this number by dividing by this one. So to find what the second number is going to be here, I go up here and divide by 7x squared. What is 21x to the third divided by 7x squared? Well, 21 divided by 7, 3. X to the third divided by x squared is x. Negative 35x squared divided by 7x squared. Negative 35 divided by 7, negative 5. And x squared divided by x squared cancels out. So that's factored. Like this? Yeah. Because there's 2 digits here. So you have to have the parentheses around them to show that that's a single number that goes together. No, because that would be saying just 7x squared times the 3x. So you have to have the parentheses to show that the negative 5 is also multiplied by it. So if I give you something like 36x to the fifth y squared minus 45x to the third. For the numbers 36 and 45, what is my greatest common factor? 9. Perfect. 9 goes into both 36 and 45. It's the largest number that goes into either. For my variables, what's the power of x going to be? X to the third. I've got x to the fifth and x to the third. 3 is the smaller of the power. So it's x to the third and my greatest common factor. How about y? There is no y in this one, is there? So if the variable doesn't appear in one of the terms, it is not part of the GCF. Think of it as y to the 0, that would be the lowest power. So the smallest power of y is not having a y in this case. So now then we're going to divide this by the 9x to the third to see what's left over. So 36 divided by 9, 4. X to the fifth divided by x to the third, x squared. 5 minus 3 is 2. The y squared has nothing to combine with, so that's still just y squared. Negative 45x to the third divided by 9x to the third. Negative 45 divided by 9. Negative 5 and x to the third divided by x to the third. Cancels out. So there we go. That factors to be 9x to the third times 4x squared y squared minus 5. So for this one, bless you, we have 35, 45, and 65. What is our greatest common factor going to be for those numbers? Careful, 15 doesn't go into the 35. 5 is going to be it. Now, if we're unsure, we can still go back and factor. 35 is just 5 times 7. That's its only factors. 45 is 3 times 3 times 5. 65 is actually 5 times 13. So the only thing that's in common there is the 5. How about for x? Now it appears 3 times. We still take the smallest of the 3. So that's going to be x to the third, x cubed. How about for y? Y to the fourth is the smallest power. How about z? Just z. So now we've got to divide that whole thing out by 5, x to the third, y to the fourth, z. So what's going to go first here? 35 divided by 5, 7, x to the fifth divided by x to the third, x squared, y to the fourth divided by y to the fourth, cancels. Z squared divided by z, just z. So then next we've got the 45 divided by 5, 9. X to the fourth divided by x to the third, just x. Y to the seventh divided by y to the fourth, y to the third. Z to the third divided by z, z squared. And finally, negative 65 divided by 5, negative 13, good. X to the third divided by x to the third, cancels out. Y to the ninth divided by y to the fourth, y to the fifth. Z divided by z is gone. So there it is. Yeah, you find the greatest common factor. We still did that right here. But then you have to divide it out to find the other factor. So you divide the number, the original number, by that greatest common factor to see what's left over. Because remember, like I said, when we took the 60, we divided out at 10. Well, we still took the 60 divided by 10 to get 6 left over. So that was factoring, one of the factors of 60 is 10 times 6. We ran into problems like this, x plus 3 times x plus 7, and we multiplied them out. Now, we did them the long way, and then we used the FOIL. I'm going to review FOIL here for just a second. FOIL, the F stood for first. So we took the first digit of each number and we multiplied them together. X times x is x squared. So I'm just going to label that. That is the F. The O stood for outer or outside. So we multiplied the outside digits. X times 7, 7x. So that was the O of the FOIL. I stood for inner or inside. So we have the inside two digits. 3 times x is 3x. That's the I of the FOIL. And then the L stood for last. We multiplied the last two digits. 3 times 7 is 21. Now we do have to combine the 7x and the 3x. So we've got the x squared up here yet. 7x and 3x makes 10x plus 21. Well, if we look at this, the x squared, that's from the F. That's from multiplying the first two digits. The 21 back here, that was from the L, from multiplying the last two digits. The 10x is from the outer and the inner combined. So I can reverse this process. If I needed to factor that, one of the things I can use is something called FOIL in reverse, or sometimes just referred to as reverse multiplication. I know that these first two digits here have to multiply to make x squared. Well, that's telling me that those two digits have to be what? X times x would make x squared. I know that these last two digits have to multiply to make 21. That gives me a couple options, only a couple. I could have 3 times 7 or 1 times 21. Let's try 3 times 7. How do I know if that's the right one? Well, I have to check to see if the inside here works. And the way I check, well, it's the outside and the inside that make that up. In fact, it's the outside plus the inside. So I do the same down here. I check the outside. What is x plus 7? Or x times 7, I should say. 7x. Then I check the inside. What's 3 times x. 3x. And if I add those together, I get 10x. Is that what I have here? Yes. So x plus 3 times x plus 7 is the correct factorization. We'll do it straight this time. So looking at this one. Now the first thing we always do when we're asked to factor, the first thing we would always want to do is look for a greatest common factor. This one has none, because the number here is a 1, so there is no number that's a greatest common factor. And there's no variable on this last term, so there's no variable that's a common factor. So the second step then is, if it's 3 digits, or 3 terms, is to go FOIL in reverse, or reverse multiplication. So let's go ahead and do that. We know that these first digits have to multiply to make, wow, I really messed that up. That should be x squared, shouldn't it? It really is going to be one of those days. We know those first 2 digits have to multiply to make the x squared. So what do they have to be? X times x, right? To make x squared. We know these last 2 digits have to multiply to make 12. Now that's going to leave us with a few possibilities. We've got 1 times 12, 2 times 6, and 3 times 4. Which one do we want to try? 3 times 4. Let's put in 3 and 4. How do we know if that's the right combination? Well, we'll check on the outside here. X times 4 is 4x. Check on the inside. 3 times x is 3x. That adds up to 7x. At this point, that will work. We will get into some that are a little more complicated. So that one is going to look very similar to this one. Of course, you can see the only difference here is this was 7x in the middle. This one's 8x in the middle. There is no greatest common factor again. So we're going to do this reverse multiplication, or FOIL in reverse. Of course, the first digit has to make x squared, so that's x times x. The second digits, the last digits, have to make 12 again. So again, that's 1 and 12, or 2 and 6, or 3 and 4. Which one do I want this time? 2 and 6, plus 2, plus 6. And if I double check it, on the outside I have x times 6 is 6x. On the inside I have 2 times x, 2x. That does add up to 8x. That's what I wanted. So that is the factors, x plus 2 times x plus 6. I made a very, very subtle change in this one. What is it? It's minus there instead of plus. Still no common factors. This first one still has to be x and x to multiply to make x squared. The second one still have to multiply to make 12. But when I made this list up here, it was incomplete. I could have 1 times 12 would make 12, and 2 times 6 makes 12, and 3 times 4 makes 12. But there's another set of numbers that does as well. Negative 1 times negative 12 makes 12. Negative 2 times negative 6 makes 12. Negative 3 times negative 4 makes 12. Since a negative times a negative makes a positive, I could also have 2 negative numbers there. So here, instead of 2 and 6, I'm going to use minus 2 and minus 6, or negative 2 and negative 6. So now when I double check this on the outside, x times negative 6 is negative 6x. On the inside, negative 2 times x is negative 2x. Negative 6 and negative 2 make negative 8x, which is what that middle is. It's negative 8x. Yep. Like here, the 6 and the negative. It's still going to end up having an x minus 6 in your result. If you say x plus negative 6, like that, you're saying? Yeah, that works. That's the same thing. All right, it took me a second to click as to what you're asking. Yeah, that's the same thing, though. X minus 6 and x plus a negative 6 are the same thing. Let's see here. Try this one in your notes. This one's actually not too bad. So there are no common factors. So we're going to try this reverse multiplication, or FOIL in reverse. To make x squared, of course, it's still x times x. The last digits have to multiply to make 2. That's pretty simple. It's just 1 times 2, but here it has to be negative 1 and negative 2. And when we double check it, it will work. X times negative 2 is negative 2x. Negative 1 times x is negative 1x, makes negative 3x. Here we try this one. So again, there are no common factors here, so we're going to be going to this reverse multiplication, or FOIL in reverse. Still x and x to make x squared. Now this one's a little different because the last numbers have to multiply to make a negative 10. So it's either going to be a negative 2 times 5, a negative 1 times 10, a positive 1 times a negative 10, or a positive 2 times a negative 5. Which combination do we want? Positive 2 and negative 5, because that's going to give us the negative 3. On the outside here, x times negative 5 is negative 5x. On the inside, 2 times x is positive 2x. Negative 5x plus 2x is a negative 3x, which is what we have there. So there is our factoring. So far, the ones we have all done have been pretty simple. You can actually look at the pairs here and pick them out rather quickly because that's just an x squared up front. But when we change it to be 2x squared, so let's say we have 2x squared plus 7x plus 6. Well, again, there are no common factors here. So we're going to do this reverse multiplication. The problem is now these first two numbers have to multiply to make 2x squared. So it'll be 2x times x. The last numbers now have to multiply to make 6. So that's either 1 times 6 or 2 times 3. Okay, the 2 times 3. Now, some of you are going to want to yell out here, but I'm going to do this on purpose for a second here. When I go to check this, on the outside, I've got 2x times 3 is 6x. On the inside, I have 2 times x is 2x. That adds up to 8x. Is that what I wanted? No. So that is not right. Doesn't mean the 2 and the 3 don't work. Because this is not x and x anymore, it's 2x times x. Now the order matters. So I'm going to put the 3 here and the 2 over here. I just switched spots with them. And now when I check, 2x times 2 is 4x. 3 times x is 3x. 4x plus 3x is 7x, which is what I wanted. So that is the proper factoring. So sometimes when you get to this point and check, it's not going to work. You're just going to have to go back and switch the numbers. What's that? 1 and 6 won't work. You think they do because they add to 7, but this is a 2 here, not a 1 anymore. So you do have to go back and check the outside and the inside like this. So I'm going to have you try one. And this is one where you're not going to get it on your first try, so you're just going to have to keep trying new combinations. 4x squared plus 49x plus 12. Yeah, the outside and the inside have to add up to 49. Well, this one and this one have to multiply to make the 4x squared. The next ones you use the 12. These two have to multiply to make 12. So then the 49 comes in when you check the outside and the inside and combine them. They have to add up to 49x. your first instinct here is to do 2x times 2x, right? 12, though, has combinations of 1 times 2, or 1 times 12, 2 times 6, or 3 times 4. Let's try those combinations. Let's do plus 3 and plus 4. See how that does. Well, on the outside, we've got 2x times 4, which is 8x. On the inside, we've got 3 times 2x is 6x. 8x and 6x make 14x. That's not 49x, is it? So, 3 and 4 don't work there. If we try the 2 and the 6, on the outside, 2x times 6 is 12x. That's looking more promising. 2 times 2x is 4x. 12 and 4 add up to 16x. Still not 49x, but it's closer. So let's try the 1 and 12. 2x times 12x. Well, 2x times 12 is 24x. 1 times 2x is 2x. 24x plus 2x is 26x. Still not 49x. Does it matter if we switch their order here? No, these are both 2x. So switching the 1 and the 12 isn't going to change anything. A lot of people get to this point and start thinking, oh, it can't be factored. Well, the problem is there are 2 ways to factor the 4x squared. We could do 2x times 2x, but we could also do 4 times 1, 4x times x. So I'll give you that hint. See now if you can find what the other 2 numbers have to be. So as we look at this, what did you try first? Pardon me? 1 and 12? Okay, so do the 12 and 1. Yes, I know. So on the outside, we do the 4x times 1 is 4x. On the inside, 12 times x is 12x. That's 16x, which is not the 49x still. But here now, because these 2 are not the same anymore, the order of these 2 matters. So I'm going to switch it and put the 1 here and the 12 here. And I'm going to check it again. Now on the outside, 4x times 12x is 48x. On the inside, 1 times x is 1x. 48x plus 1x is 49x. That's what we want. So there's our factoring. If those 2 are different, yes. Basically, some of these are an exercise in exhaustion, of trying every possible combination until you can't. I mean, there are going to be some that can't be factored. You have to try every possible combination before you can give up on them and say, nope, they can't be done. Okay. There is a new quiz that is due tomorrow for Thursday at 11:59 p.m. There is a new homework. Now, I don't remember now if I made that homework due. Does it due the 27th after? I can't remember if I made it due next Monday or the Monday after spring break. But if it's not due the 27th, I'll leave it so you can still work on it till the 27th. So you have a week and a half to do that homework. So tomorrow we'll do more examples of this and do a little bit of a review before we go into spring break. And then we got next week off.